Morning student, today I have came a new video of the crystal. We are going to the application of learn this. It is very helpful in final and Taylor distortion. How this is done can be applied best. This is the crystal found lattice and their crystal and okay, when this complex type of oxygen and metal here access the polystructure. Therefore, there are lots of colorful finals here, and final use of CFSC. That final name is given by mineral magnesium and aluminum ore. Is has a structure of A, B, and normal spinel oxygen from cubic array. Magnesium A type sit in tetrahedral sites, and aluminum B type octahedral sites. That is Mn2 tetrahedral and Mn3 tetrahedral give you 4. An inverse spinel is 20 half of the divalent ion swap divalent ion so that magnesium to 2 pi octahedral site, that is BAB, and that is manganese and manganese 3 and 2 octahedral. Final use of spinal use of CFSC is that CFSC is highly used and whether structure is normal or inverse. It's found that if manganese 2 3 plus metal 3 plus ion has a higher CFSC and octahedral field compared to the metal ion, normal CFSC is tetrahedral Mn2, tetrahedral 4. If Mn2 has a higher CFSC and octahedral field, metal 3 plus ion, inverse spinel will result. Is inverse metal 3 tetrahedral Mn metal 2 and 3 metal Mn. Final use of CFSC. Example is manganese 3O4. Oxygen weak field ligand, that is Mn plus D5 2, no CFSC, and manganese 3 D4 2G3 1 is minus zero point 0.6. Normal structure is normal spinel. How about Fe3O4? It is find this structure. Negative is a normal structure. So if we want to get the details of Fe4 hydrophilic site, the spinel use the CFSC, then if 4 oxygen weak can plus 6 for EG give you minus 4, and 3 plus D5 is the, you can find it is high spin complex, 5 it is spin. So there is no CFSE variation in, that is why it is different type of spinal can. Next important distortion is observed. You can find when there is it is if it is regularly filled 2 and 2, 1 and 1, then there is no problem. Your octahedral structure is. But if it is 2 and 3, 2 and 1, that is asymmetrically filled, that is actually asymmetrically filled of E or T2G orbital, then there is a problem. Is PG configuration, if it is Z1, D2, then ligand along XYZ will repel more and bonds elongated. That octahedral will be compressed along the Z axis. Consider the configuration dj square 2, dx square 1. Ligands along Z minus, Z plus and Z minus will axis will be repel more and bonds along bonds elongated. That is, the octahedron will be elongated along the Z axis. And if we found that giant-tailor distortion, this if it is the Z elongation and Z elongation, then it will be d Z square. Then it will be dotted like this, and T2G will be d Z YZ and configuration. When it is Z compression, then Z square will be higher energy, that is destabilizes, x square minus stabilizes, and x square yz this will stabilizes configuration. So you can find Young-Taylor distortion gives us about the idea of asymmetrical field in Z elongation and Z compression, Z plus or minus axis gives us details of this distortion or currency energy, how this is have been found. Young-Taylor gives us from higher asymmetric low degenerates low. Special case occurs when the 8 octahedral complexes of nickel, palladium, platinum, copper, etc. There, there you can find the d square 1, 1. So it has been found that this energy, there is a splitting, and this splitting like this, and both z square or dx square is completely filled like this, and square planar complex is formed. Attempt to form the octahedral complex become possible. D8 complexes have been has a special case, and it has been found that this square planar complex is formed instead of octahedral regular because of this splitting Jahn-Taylor exertion. So if we compare this, the energy versus square planar tetrahedral details of it, you can find square planar is z square minus 1 dj, and if we have square trigonal TBP structure, this when we have square planar structure, this is this splitting. When you have octahedral complex, this is the splitting. When you have pentagonal biplanar, the splitting. When you have square antiplanar. So if you have a different structure, different antilar is the application of the octahedral field after crystal field theory, and how this is done can be explained with this Thanks a lot. As I think I have quite explained this phenomena of the gentile final. If you have any doubt, you don't be in my college website MC.net delighted. If you have any query, I can say answering you. Thanks a lot.